Welcome back at SAS Squared. In this lesson we will talk about relationship between two triangles that have corresponding congruent sides. However, you'll notice in this picture the angle included is not the same. So yes, these two sides are the same. They have the same measure, AC congruent with DF, or the measure of AC is the same with the measure of DF. Also, we notice AB and DE, they have the same measure. Okay, but we notice now the angle included, this one is 36 and this one is 53. So the measure of angle A is less than the measure of angle D. Therefore, we can say something about the third side. The third side here, ABC, is less than the third side in the other triangle, FE. And you can see here I have all these numbers just to show you this relationship in this triangle. What you see here can be summarized in this Hinge theorem. How is called the Hinge theorem, or the angle side inequality theorem. And you notice we have two pair of corresponding congruent sides, AB congruent with DE. Also AC is congruent to DF. But this angle is larger than this angle. Therefore, EF should be greater than BC. That's what this Hinge theorem said. And you can see this, the picture. Let's see how we use this Hinge theorem. Okay, and if you notice here, we have this side and this side are the same. They are congruent. They have the same measure. ML equal with OP. NL, it's also congruent to OQ because they have the same measure. But if you notice now, this angle is 56 and this angle is 123. So we can write this relationship, and because I start with the triangle that contains M, L, and N, I'm going to start with angle L. Angle L is less than angle O. We notice 56 and 123. Therefore, we can say what? We can say that MN it's less than QP by the Hinge theorem. Okay, so this is the relationship between MN and QP. Of course, you can write the other way, QP greater than MN. Both of them are correct. Let's take a look to an example like this when we have triangle that share a common side on both picture. So we are asking part A to find the right hand inequality relating these two segments on BT and DC. If you notice here, we do have two triangle. We have ABD. I'm gonna try to draw it here. And we have, oops, let me try to be kind of consistent. We have the second triangle. Let me try something like this, ACD. Okay, so if you notice, I redrew the picture and I split the triangle. And if you notice, we have these two sides congruent, AB and AC, we can see in the picture. And that's what I meant by they share this common side, AD, right? So we have the conditions for the Hinge theorem. We have two corresponding congruent sides. AB is congruent with AC, and AD is congruent with itself, AD. So we have this condition. Now we look into these two angles and we notice what? This angle is greater than the other one because it's 34. The measure of angle BAD is greater than the measure of angle DAC. Let me write the angle not. Okay. DAC. How do we know that? We see one is 34, the first one is 34, the second one 27. Therefore, what can we say? We can say that AB, okay, I'm sorry, BD, because that is on the other side of the 34. BD should be greater than DC by the Hinge theorem. On part B, very similar problem, the only difference, we want to find how much this angle here, and that one will be 180 minus 78 because they form a line, they are a linear pair, and that will be 102 degrees. Other than that, we notice these two sides are congruent, they are marked the same. This is a common side, so very similar with what we have here. Therefore, the condition for the Hinge theorems are accomplished. We can say Mn is greater than Mt. Why? Because the opposite angle, this one is 102, which is more than this opposite angle, which is 78. So again, by the Hinge theorem. You can have picture like this. Also, you notice we have a common side on part A, but also you can redraw this triangle. I'm going to try to do it. Okay, this is the first triangle. Okay, one more time. Let's try one more time. Okay. So this is the triangle PMN. And then we have this triangle. And this is T. This is N, this is M. You notice these two sides are congruent. And this is a common side. So they are congruent. So again, the condition for using the Hinge theorem are accomplished, two corresponding congruent sides. Also now we see here the measure of angle PMN, this one, is greater than the measure of angle MNT, this one. Okay, so now because this is PMN is greater, that means this side, which is on the other side of the angle PN, has to be greater than the third side of the other triangle on the other side of angle MNT, and that would be MT. Okay, so this is the relation for this problem. Let's move to part B. And here we notice again these two sides are congruent and these two sides are congruent. So again, the condition for applying the Hinge theorem are accomplished. Then we notice this angle is 74 and this angle is 37. Because this angle is 74, which is more than 37, that means CE has to be greater than the side on the other side of the 37 degree angle, which is ED. Now this is the relationship that we can find in this example, in this problem part B. Okay, there is another theorem, like I said at the beginning, it's the converse. which is the opposite, the inverse of the other theorem, and it's called also the SSS, side inequality theorem. If two sides of one triangle are congruent to two sides of another triangle, we can see that in this picture. These two sides are congruent. These two sides are also congruent. And the third side are not congruent. We can see here they are not congruent. Even more, we can see the larger side is EF. EF is greater than DC. Then the larger included angle is opposite to the larger third side. So EF being larger, that means this angle will be larger than this one. Okay, so this is the converse of the Hinge theorem of the side inequality theorem. Let's see how we use this one. And you notice now in this type of problem we have all sides given. But what do we notice here? We notice this is 5, this is 5. So we have BC equal the measure of BC equal the measure of DF, both of them being 5. And also we notice these two sides are congruent because they have the same measure of 6. So AB is equal with DE. Now we're looking to the third one and we notice this is 4 and this is 3. AC is greater than FE. Therefore, from these three things we can say this angle, right, which is on the other side of the side that is 4, so the measure of angle B will be greater than the measure of angle D, which is on the other side of the side that is 3, by the converse of the Hinge theorem or side inequality theorem. Very similar, we have multiple triangles here, but let's see if we can use what we just learned. And we notice here these two sides are congruent. They are marked the same. This one is the common side, BAB, so the condition for the converse of Hinge theorem are accomplished. Now we notice this is 53 and this is 38. Now, since this side is larger, that means this angle is larger than this angle. So the relationship will be the measure of angle ABC, it's greater than the measure of angle ABD. This is 1A. Obviously you can write it the other way. The measure of angle ABD is less than the measure of angle ABC. Okay, and now we can move to part B. Very similar. We notice that these two sides are congruent. This is a common side, MN. And then we notice this is 72 and this is 78. So that means that angle RMN, this one, is what? Less than the measure of angle T and M. Why? Because we can apply the converse of the Hinge theorem, of the side inequality theorem, and we notice this is 72, which is less than 78. So the angle on the other side of these two sides follow the same pattern. Of course, you can write this one the other way if that is needed. The measure of angle TNM is greater than the measure of angle RMN. Okay. In some cases, you'll have to apply algebra to relationship in the triangle, like in this example here. Use the figure below, find the range of possible value of x. So first of all, you should notice these two sides are congruent, very similar to what we did before, and this is the common side. So now we're looking, this is 46 and this is 39. So that means this angle here should be more than this angle here, because 46 is more than 39. So I'm going to write like that. The measure of angle GFL should be greater than the measure of angle KFL. Why? One more time, this is 46 and this is 39. 46 is more than 39, and that means the opposite angles need to follow the same pattern. So what will be the equation inequality, in fact, we can write here? 2x plus 16 should be greater than 64. I'm going to subtract 16 here. And we have 2x greater than, and that will be 48, and divide by 2, we get x greater than 24. But you notice it says find the range of possible value. This is not good enough. We need some other thing. And the other thing will be by the fact that this angle GFL needs to be less than 180 degrees, right? So that will be 2x plus 16 has to be less than 180. I'm going to subtract 16 to solve this inequality. We have 2x less than 164. Divide by 2. X has to be less than 82. Now we're just going to put these two guys together and we're going to say, hey, x needs to be less than 82, which is the second inequality, and greater than 24. This is the range that x can take. It can be between 24 and 82, and then this relationship in these triangles are accomplished. A very similar problem here, however a little bit different, right? So again, we take a look, we notice these two sides are congruent. This is a common side, so we can apply either the Hinge theorem or the converse. It's going to be the converse because we notice we have a third pair here, and we notice LK is greater than GL. That means angle, so LK, the angle that is 52, right? This angle should be greater than this angle, which is 2x plus 14. So we're going to solve this inequality. Again, I'm going to subtract 14. And here we have 38 greater than 2x, divide by 2. you have 19 greater than x or x less than 19. So that will be one relationship, and what will be the other one? This angle 2x plus 14, angle GFL, needs to be greater than 0 in order to have a triangle. So we're gonna subtract 14 here, and we have 2x greater than negative 14 divided by 2, x needs to be greater than negative 7. We're gonna put these two together, and we're gonna have x less than 19 and greater than negative 7. This will be the range of possible value of x. X can be between negative 7 and 19, and then we have what you see in the problem. Finally, let's see a proof. And in this one we have given that AB congruent of AC congruent of AD congruent of AE. Okay, and then we know that the measure of angle BAD, this one, is less than the measure of angle DAE. So my first thing will be to redraw the picture here, and I'm gonna try to do it here, something like this. This is the first triangle, ABD. These two are congruent, and we have this angle is mentioned. Then we have the second triangle, ACE. All these four sides are congruent, and then we have this angle which is greater than the previous one. Okay, so can we use the theorems we learned about? Yeah, we can use the Hinge theorem, the angle side inequality. Why? We have two pair of corresponding congruent sides. Yeah, these two. In fact, all four have the same measure. And then we notice the angle included are different, so we can apply Hinge theorem. And that's the thing I'm going to put it in this proof. I'm going to do a 2-column proof, but you can do a flowchart also. So statements, and reasons. And we notice the first thing I'm going to write here, it's AB congruent with AC, and that is given. Then also AD congruent with AE. These are the two corresponding congruent sides. In fact, all four are congruent, right? And this is given also. So we have the side and side in the side angle side inequality theorem. And then the next thing is given to us is the measure of angle BAD is less than the measure of angle DAE. Again, this is given to us. Okay, and yeah. I'm sorry, in fact, let's take a look one more time. I think I said here BAD, this angle, and DAE. Yeah, so because of I think I should have here, let me erase. Yeah, I think here I should have the measure of angle BAC is less than the measure of angles DAE. That's the thing. Okay, and but other than that, we good. We have also this angle here that is going to be on both triangles, so then we can apply Hinge theorem. So one more time, let's do the proof statements and reasons. And yeah, we're gonna start with the same thing. A, B congruent to, let's say, AC. This is given. Then we have AD congruent of AE. And again, it's given. And then let's take a look what we have here. The measure of angle BAC. It's greater than the measure of angle DAE. Let me erase this. I will put it again in a moment. Okay, so also this is given, but now look at here what I'm gonna do to prove what I need to prove. I'm gonna bring this angle, which is angle CAD, measure of angle CAD. It's equal of itself, and this one is what we call reflexive property of equality. Okay, now we're gonna add these last two statements, and I'm gonna have the measure of angle BAC plus the measure of angle CAD has to be greater, right? We add the left side, we add the right side, than the measure of angle DAE plus the measure of angle CAD. So we add the same quantity, right? So that will be the addition property of equality. You add the same quantity. Now let's take a look to each sum of the measure. This one on the left, the first one, what is that guy? That is going to be the measure of angle BAD. So let me write that here. The measure of angle BAC plus the measure of angle CAD is nothing else than angle BAD, the measure of angle BAD. And this will be the fact that we add those two angles and we get the big angles, and that will be the angle addition postulate or protractor postulate. You can here add in these both ways. And we're gonna write the same thing about the right side. And here I should have put angle. And here we have the measure of angles DAE plus the measure of angle CAD, the second group, right? That will be the measure of angle CAE. And it's going to be the same reason, angle addition postulate or protractor postulate. Now we're going to replace in this statement here by what we have in these two statements. So we're going to have the measure of angles BAD is greater now than the measure of angle CAE. That will be substitution property. And now let's take a look. Do we have everything we need for the Hinge theorem? The answer is yes. We have these two corresponding congruent sides. We have this angle which is greater than the other one. So obviously now we have what we need, which is, and I'm sorry, I think, yeah, I missed the thing. It's BAC. Okay, this was less here. So it's going to be less, and it's going to be less. I apologize. So less, less, and less. Okay, so now we can say BD is less than CE by what? By the side angle side inequality theorem or Hinge theorem. Okay, and that's it. Okay, we prove what we need to prove. If you enjoyed this lesson, don't forget to click the like button and come back on C-Square for more help. Thank you.